As a result of that, we had to do it individually. In this video, I will be talking to you about the civil engineering projects that I did while I was a student. These projects are for classes that are project-based, and not every single project that I did while I was a student. I'm just giving you the good information that I think people interested in this sort of information may be interested in. If you're new here, my name is Dem. I am an entry-level civil engineer. And on this channel, I talk about my civil engineering experiences while I was at school and after graduation. So if you're interested in this sort of content, make sure you subscribe so that you don't miss anything. And with that, let's get into today's video. So for the purposes of this video, when it comes to the project reports, I will show you only the table of contents, mainly because a lot of these projects tend to be recycled, and I don't want to be in a situation where I am contacted by the school about that. But I will be showing you the construction plans that I did for my senior design project, because that one was very unique, and it's a situation where I don't think the conditions when we took it will happen again. So let's just get right into it. The first project-based course that I took was in my sophomore year, my second year, and this was roadway engineering. In this class, we were redesigning about a mile of US 33, which is found in southeastern Ohio. We're about 10 of us, 10 groups, I believe, and so they took the entire stretch of US 33, divided that up, and then gave it to teams to redesign their own section. And so that's what it was. And so at the end of the day, we were supposed to give a project report and construction plans. Unfortunately, I do not have a copy of the construction plans, but I do have the project report. So I'm going to flip the camera for you to see the table of contents when it came to the project report. So what you're looking at right now is the table of contents for our project report when it came to the redesign of US 33 Nelsonville bypass. So for our project, we decided to start first with an introduction section. So this is basically a snippet of the entire report itself. And so we have a purpose, we have information about the surrounding environment, the challenges that we faced, the conclusions that we came to, and information about the team members and what we did. And everything after that is basically the design of the roadway. The design controls came first, and then we went ahead to select what route we're going to use. And then once we select the route, we go ahead to design the horizontal and the vertical alignment. Next, we had to do super elevation, staking, cross sections, the mass hole diagrams. So this is all step by step what we had to do for this project. It also came with project plans, which was quite a thick document. But yeah, this is what the table of contents looked like, and it was roughly about 34 pages, and this is how thick the document was. For this project, on my team, we were 5 of us, and the workload was spread out pretty evenly among all of us. As to what I did, I worked on the hand calculations mainly, wrote out information on the curve analysis, and I did the super elevation design. So that's mainly what I did. I didn't do anything CAD related because other people had that figured out, and I've never really had exposure to CAD before. So when it came to actually completing the project, we used Excel, Word, and AutoCAD to create the construction plans. When it came to the amount of time that I spent working on the project, on average it was about 10 to 15 hours. What I did came easier to me because I like the calculation side of it, and CAD was not really my strong suit. The people that were working on CAD probably spend so much more time on it because CAD itself, it's one thing, and making sure that things align properly is a whole different ball game. So depending on what you're working on, you might put more time or less time, but on average I did 10 to 15 hours a week. So how was it working with the team? So for me specifically, I didn't have any issues with them. Everyone was really on task. Whatever they said you should do, they did it. And we had a project lead, and she was really good at making sure that everyone was doing their job properly. So everyone was really on top of things, which made things so much easier and much less stressful. The second project-based course that I took was called Traffic Signal Systems. I took this in my senior year of college, and to tell you what it was about, I have to read it off of my screen because it's pretty lengthy. And so we were redeveloping a traffic signal coordination and progression plan for a street located in Athens, Ohio. Essentially, to translate that into proper English, there were a bunch of intersections back to back along this street, and we were tasked to retime the entire system to make sure that someone can start at the very beginning of a signal and drive all the way through all those signals without having to stop. That is what we were doing. And so at the end of the day, the project deliverable was to give a project report, which I will show you right now. So what you're looking at right now is the project report that we did for our traffic signals project. This was in a 1/2-inch binder, which was pretty lengthy, mainly because of the appendix. This is what our table of contents looked like. So we started off with an abstract. So basically, if you don't want to read the entire report and you just want to get the gist of it, you just had to read the abstract. We had, of course, the list of tables, figures, and we started off with an introduction, pretty much introducing what the project is about, existing conditions, what is going on, and why we are doing this. For the next chapter, we have a warrant analysis. So whenever you're putting in a signal or you're trying to retime a signal, you have to justify if that signal is actually needed at that location, which is a warrant analysis. I believe there's 7 of them that you have to run through. But yeah, we have to justify that a signal is needed at this location. Once it's justified, we can go ahead to create phasing plans. And then next we did a progression analysis. So we're analyzing the entire system that we created, making sure that it works and it doesn't cause a lot of delay on this particular street. And then next we went into the conclusion, basically summarizing everything and providing our recommendations. And then of course we had an appendix section, which pretty much is the output from the software that we were using. So now that you have taken a look at the table of contents for the project report, you can tell that there's quite a bit of work that went into this. So when it came to what was done, we were looking at 7 intersections. And so I took 4 while my teammate took 3. And I'll list out exactly what we did for those specific intersections. When it came to the programs that we used mainly Excel, Synchro, and SimTraffic. We used Excel because there's a lot of iterations going on, and so once we have a value that we're happy with, we feed that into Synchro and SimTraffic for it to simulate the traffic situations. When it comes to the amount of time that I spent on this project, personally, I did about 20 to 25 hours a week, mainly because of Synchro and SimTraffic. When it came to those particular software, it's not like we were taught how to use it. It's not like when I took Intro to AutoCAD, where there was a specific class that actually taught you how to use AutoCAD. With Synchro and SimTraffic, we didn't have that luxury, so we had to learn these things on our own. And I used to spend a lot of late nights in the computer lab trying to figure it out. So that's why I put in so much time. But once I figured it out and knew my way around the program, it went down to about 10 to 15 hours. So how was it like working with my teammate? So at the time, my teammate was in his final semester and he was taking his senior design project. And every civil engineering student knows that this particular senior design was heavy, and I understood. And so me, that I enjoy traffic, I was happy to do a lot of the work. And I would say I did probably 70%. I was pulling a lot of the weight and leading the project so that we could, at the end, have a good grade. But yeah, it was not a fair share of work. But I think when it comes down to understanding each other, like why this is happening, I think it's better that way. I'm not saying that he did not do his job. He did what he needed to do. I was leading the project and telling him exactly what he needs to provide. So that he did. So I think it just boils down to you having that conversations with your teammate, like, okay, where is everybody at? Making sure that everybody is on task and we understand each other regardless of what's going on. Once you have that conversation, I think it's easier over time rather than someone ghosting the other person just because. The third project-based course that I took was in my super senior year. So I did 4.5 years of college. So that extra semester is what I call my super senior year. And so in that last semester that I had, I took a course called Water and Wastewater Engineering, and that was a project-based course. And so for the project, we had to design a water treatment plant for a city of our choosing. So what the professor did was to provide hypothetical test results of the water sample that is going to be distributed to these people of the city of your choosing. So unfortunately, I cannot show you the project report because we did not have a table of contents. I know we were seniors at the time and we missed the one thing that is very important in the report, the table of contents. I don't know how that happened, but it did. And so what I will just do is just to give you an overview. So the project report itself, so the writing aspect of it wasn't long, it was about 10 pages. We were just designing a water treatment plant to address some of the contaminants that we found in this particular water. So we had created a whole system which could get out each of these contaminants out of the water and then get redistributed to society. So when it came to what I did on this project, I designed one of the treatment processes that was used for this entire water treatment plant. And so yeah, that's what I pretty much did and wrote a little bit on the reports, but it wasn't lengthy as a lot of the other project-based courses were. Yeah, so yeah, that was pretty much that's pretty much what I did. I would say this is not the perfect example for how a project should look like. We were in our last semester and a lot of our focus was on other things like trying to figure out what happened after college. We had senior design going on. So it really showed what was going on in that particular semester because so much was going on that you could not put 110% on each and every single project. Because what I did was to put so much effort in my senior design, which I was also taking at the same time. And I didn't really focus too much on this project. So, but for this project, we were 4 of us. We have known each other for like 3-4 years going. And so it was really nice working with them. There were times when we would just hang out, we'll have dinner, and it was a very casual, very relaxed working environment. And yeah, I enjoyed working with these ladies, and each of them are in their own separate worlds right now, doing different things and being successful. So it's always good to see. And when it comes to how much time I spent on this project, I spent about 10 hours or less on this project. I really did not put too much effort because a lot of my time, as I mentioned, was on other things like my senior design project, which I will talk about next. For my last project-based course that I took in college, it was my senior design project, land development. This course was a test of my ability of how much I knew what I said I knew. If I made it to this point, I better show it. And this was the class. I took this class in my last semester of college, which was in the fall of 2020. And we all know that 2020 was when everyone was remote and I had to take my senior design course remotely. This project has been designed to be in person. It has been designed for students to work together, to think together, to figure things out. And unfortunately, since we had to be remote, due to everything shutting down, our professor, God bless her heart, she had to come up with a way for us to do our senior design remotely to the same quality that previous people who took the senior design course did. And so as a result of that, we had to do it individually. and she made it clear why she did it like that, and everybody understood why, and we're just like, we just thank you for putting this thing together. So what was the project about? The project was to design a residential subdivision, and in order to properly show you what we had to do, let's switch over and I'm going to show you the plans, the construction plans that were created from this project. So this is what was created from our senior design project. All of these sheets was created by me and me alone, and so yeah, this is what we had to create. So as you can see from the table of contents, there are about 39 plan sheets involved in this entire set. So now running through this entire plan set. So first off, we have the survey plat. So basically what survey is gonna lay out. I am not very versed in surveys, so I just want to give a quick shout out to Mariah, who helped me write this description. I have no idea how they do it, but I trust her completely. So thank you, Mariah. So next we have the existing topography. So basically what the land looks like. It was a pretty flat area, so nothing too serious going on here. So next we have the subdivision layout overview. So basically this is how my residential subdivision looked like. Pretty straightforward. The professor wanted just a single lane, nothing too crazy. Normally if you're in person, this is much more crazy than this, but for our sake and her sake, we just made it a very simple residential subdivision. So right now what you're looking at is the proposed contours. So I fixed what was before and made it like this. And so the more squished, like this area, the more squished the lines are together, the more steep that particular area is, and the more space there is between the contours, the more flat that area is. So this gives you an idea of what's going on here. So now right now what you're looking at is the plan and profile. So the easiest way that I can explain this, when you go on Google Maps, right, and you're looking at the top-down view, you're looking at the road to the nearest Chipotle to go buy food. This is what this is. This is your top-down view. And then if you take that top-down view and you flip it like that, and you actually see like how bumpy the road can be, this is what that is. That's what is called the profile view. And so you can see the existing grade or the existing ground, how it looks like. And then when we decide to build this residential subdivision, which is going to have a nice slope at a grade of 1.25%. So pretty smooth, very straightforward. Okay, so right now what you're looking at is an overview of all the utilities involved. Let's just say, for example, we're living in lot 6, right? So you're making sure that you have water, you're making sure that when you go to use the bathroom, the water gets out, and so that's your sanitary. And then whenever the rain falls, you're not left with a pool of water around your house. So we're making sure that it's being drained properly into the detention basin. I don't know if you can see, but each of these lots or houses will have a connection to the water and the sanitary sewer. Okay. All right, so this is just a closer view of the utility layout. Let's just pick out lot 8, for example. So as you can see, it has a connection to the water, and then there is a connection to the sanitary sewer. Where is that? Yeah, this is it right here. So this is sanitary, so all the waste water that is coming out, that will come out from this house, will go here, and then the water goes in here. So we have that for each and every single home. Okay, so this is where things started to get very technical. It's one thing to just lay out where the utilities are going to go, but it's another thing to make sure that the system works. And so in order to make sure that it works, we don't only need the plan view, we also need to know what is going on the ground, and that is when we have the profile view. And for this is the water main profile. So this is how the water is going to be distributed along these homes. And so as you can see, lot 24 will connect right here, 23, 22, 21, 20, and this is 119, and it keeps going all the way up. Okay. And so now what you're looking at is the plan and profile for the sanitary sewer. As I mentioned, the sanitary sewer is the water that is being removed from the homes. So when you go to the bathroom, when you go to shower, the water that you've used needs to be removed, right? And so that's getting removed through the sanitary sewer. And so this is the pipeline for that. So this little dot up here is a water connection to these homes and the different lots. And so what you're looking at right now is the drainage map. So as I mentioned, when water falls, right, you don't want a situation where there's a pool of water in front of your house. So we have to make sure that the water is being removed and placed at a location that it will not disturb the residents. And so we create drainage maps and a drainage design to make sure that we are collecting all the water that is being poured on these residential lots, and we are taking away a lot of that water as much as we can, so that you don't get into a situation where you have a pool in front of your house. All right. So just like the water main and the sanitary sewer, we need to show how the storm sewer looks like underground and if the science works. And so that's why we show the storm profiles. So this is the storm sewer profiles for this residential subdivision. So we're civil engineers, right? So we have to justify a lot of the things that we do using the math that we know. So for this table, this is justifying that the storm sewer design works. This is basically what this is. And then you have your intersection details. I would say I didn't really put too much effort into this. And then everything after that is just your standard details. So these are the construction plans that I produced for my senior design project. And now let us talk about the report. So like I mentioned, I will be showing only the table of contents for the reports. And so basically everything that you've seen on this set of plans, I had to explain what I did in the project report. So imagine these plans converted into words. This is what this is. And so the way I structured my report is pretty much going through step by step. We started first with survey, and then we next looked at the transportation aspect of it. Then we did the roadway design, and then we did the utility design, sanitary sewer, water main, storm sewer, the soil management, and then I also included what the design schedule was for me. That I will show you. So this is pretty interesting. This is basically the amount of time that I took to do everything that I did for this project. You can pause to take a look. And once you looked at it, you really see I took about 70 days. I started August of 2020 and then it ended very early December of 2020. This was a cherry on the cake. This was my final design. This was my civil engineering knowledge all in one. And yeah, this was it. This was my senior design project. So you've seen my senior design project. This project, I poured my heart and soul into it. I cannot describe how much I put into this project. I did really well on the project when it came to the amount of time that I put into this. Like the design schedule that you saw is in days, but when it came to the number of hours, I think it started off with about 10 to 15 hours a week for the first month, I believe. And then as it got closer to like submission dates, I put in about 25 to 30 hours on this project. It took a lot of my time, but I think it was worth it. It was really worth it, and I was challenged. I was really challenged on my knowledge on what I knew and how I knew to design. This is when I really got to interact with CAD quite a bit. I use CAD, I use Excel, I use Microsoft Word, of course, for the report. So it was very, very tasking, but it was worth it at the end. If you made it through to the end of this video, wow, you are a trooper. This video was about almost 30 minutes long and you made it through. I hope this was valuable to you and you learned something new that you didn't know about when it comes to being a civil engineering student and the types of projects that you may be involved in. If you enjoyed this video, give it a like so that other people interested in this type of information may find it. And so with that, I will see you next time. Okay, all right, so I don't have any bloopers for this particular video because it took me almost 3-4 days to edit the content for this video. So I don't know, I think all I'm gonna say is thank you for watching this video if you stayed all the way to the end. I hope that it's valuable information to you or wherever you are, and it inspires someone out there to go for a civil engineering degree because we need them so much. My intention of this video is not to scare anyone that, oh wow, there is so much work that goes into it. I cannot be a civil engineer. My intention is to give you the reality of things. So yeah, I hope it really I hope you enjoyed the video. Give it a like. If you have questions, please let me know in the comments and I will respond the best way I can. And with that, that's the blooper for today. See you next time.